Algebra 2 students, going to try to make this quick, but we got a lot to talk about. So, I think you should be able to graph any exponential function of the form a times b to the x minus h plus k. One of the things I did not talk about when we graph these functions is the domain and range. And what is important is the domain and range. So all exponential functions b to the x look like this, or depending on the value of b, they could look like this. And then depending on the value of a, they could be flipped to look like this, or they could be flipped to look like this. One important characteristic is that the domain is all reals. You can plug in whatever you want for x. It will always work. You might get something so infinitely small that it's practically zero, or you may get something so large you can't even fathom how big it is, right? Just tell your calculator to do 10 to the 1 million or 2 to the 1 millionth power. It's not going to work out well. It exists. It is so large, I can't even comprehend how large it is. But it exists. I can plug in whatever I want. And if you want to get a really small number, just make it a negative 1 million. You can raise any base to any power you want. The domain is all reals. The range is important. And the range, depending on the a value, is that y is bigger than k, or it could be that y is less than k. So in these four examples, if the top two you have y is bigger than 0, and in the bottom two you have y is less than 0. Now, two important characteristics we've talked about before in Algebra 2. One, these are all functions. They pass the vertical line test. More importantly, they also pass the horizontal line test. What that means is that all exponential functions are 1 to 1, and this is a hugely important trait for what we're going to talk about in this video. When a function is 1 to 1, what it means is that if f of a equals f of b, a has to equal b. So an example of a non-1-to-1 function would be x squared. F of negative 2 equals f of 2. Right? If I plug in 2 for x here, I get the same thing as if I plug in a negative 2. This function, though, is not 1-to-1. It fails the horizontal line test. When a function is 1-to-1, if f of a equals f of b, then we know a equals b. That's a big property for exponential functions. All right, a little sidebar here of things I think you should know if you are going to be a successful Algebra 2 student. You should know that 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, 2 to the ninth is, did I get these wrong? 5, 6, 7. 2, yes, I think I skipped one. 2 to the 6th is 64. 2 to the 7th is 128. 2 to the 8th is 256. 2 to the ninth is 512. And 2 to the 10th is 1024. All of you in my Algebra 2 class have 10 fingers. I would have known by now if you didn't. You need to know how to get all the way to powers of 2 all the way up to 10. With 3, you don't have to go quite as high, but I think you should be able to get pretty far along. After 27, 3 to the fourth is 81, then 243, and if you really want to impress me, go all the way to 729. That is 3 to the sixth. Also 9 to the third, but this shouldn't be hard to see that it's also 3 to the sixth. 4, 16, 64, and then what do we have? 256 after that? 5, 25, 125, and then we've got 625, 6, 36, 216, 7, 49, 343, 8, and then 64, and 64 times 8, 512, 9, 81, and then 729, 10, right? Pretty easy with 10. Good. I think you should know these. I think you should be able to write them down. If you don't know them, you should at least recognize them and then be able to grab a simple calculator and figure out what they are. The reason you got to know them is because you are going to see these numbers a lot. And if you see 243 and you don't know it's a power of 3, you're not going to do well in this unit. If you see 216 and you don't know it's a power of 6, you're not going to do well in this unit. And if you don't recognize 1 over 243 as 3 to the negative fifth power, you're also going to struggle in this unit. These are things you should know. Write them down. Be familiar with them. Use a chart for now, but get used to seeing them and know them. Other things I'm taking for granted. You better know that a to the m times a to the n is a to the m plus n. That's algebra 1. You need to know that a to the m to the n power is a to the m times n. You need to know that a to the negative n is 1 over a to the n. And so help me, Algebra 2 students, if you tell me that this is negative 8, I am sending you back to Algebra 1. You're not ready for Algebra 2. You're not ready for Algebra 2. As a matter of fact, think about the graph of 2 to the x. It looks like this. How could you get a negative 8 value down here when y is required to be bigger than 0? How could you get a negative value? You've got to know your exponents, and these are really the only ones you need to know. All the others are just different manifestations of this. So why are we talking about all this stuff? Because as we study exponential functions, we're also going to study exponential equations. And I'm going to give you a problem like this. 243 raised to the x plus 2 power times 9 to the 2x minus 1 power equals 9. So how are you going to solve for x? Well, what you're going to do is you're going to say, hey, all of these are powers of 3. So I'm going to start right there. This is 3 to the 5th to the x plus 2. And then this next one is times 3 to the 2nd to the 2x minus 1. And then that equals 3 to the 2nd to the first power. And then you're going to simplify using your exponent rules, and you're going to say, okay, this is 3 to the 5x plus 10 times 3 to the 4x minus 2, and that equals 3 to the 2nd. And then you're going to use your exponent rules and say, okay, this is 3 to the 9x plus 8, and that equals 3 to the 2. And then you're going to go back to what I said at the beginning of the video, which is the graph of 3 to the x is a 1-to-1 function. And what that means is if 3 to the a equals 3 to the b, then a has to equal b. So in this case, I know that 9x plus 8 has to equal 2. That means 9x has to equal negative 6. And that means x has to equal negative 2/3. And because exponential functions are all reals, it doesn't matter what power I raise these to. I got a real number, I can plug in any real number I want, so negative 2/3 works. Later in this unit, we're going to have restricted domains, which means you better check your answer to make sure it works. But right now, you can plug in anything you want. All right, I know I went super quick through that example, but that's because you kids hate long videos. So try this one on your own. 64 times 16 to the negative 3x equals 16 to the 3x minus 2. Every exponential equation I'm going to give you. Now let's go back here. So we did polynomial equations. That's when you have polynomials equal polynomials. Now we're doing exponential equations. That's when you have exponential functions equaling exponential functions. Right now, I can only give you exponential functions where everything can be rewritten as the same base. So try this problem on your own. Couple ways to do this if you didn't pause the video. I'm going to do this 4 cubed times 4 to the 2nd to the negative 3x equals 4 to the 2nd times 3x minus 2. You could have also done this with powers of 2. If I had also multiplied this by 32, because 32 is not a power of 4, then you would have had to use powers of 2. But since that's not in the problem, you could use powers of 4. So what does that mean? Well, now this means that we have 4 to the 3 times 4 to the negative 6x equals 4 to the 6x minus 4. All right, we simplify over here with our exponent rules. I get 4 to the 3 minus 6x equals 4 to the 6x minus 4. And then I'm going to make a jump and I'm going to say I know that 3 minus 6x equals 6x minus 4. And why can I say 4 to this power equals 4 to this power? That must mean the powers are equal. That's because 1 to 1 functions. If exponential functions were not 1 to 1, we could not do this. Add the 6x to both sides, add the 4 to both sides, I get 7 equals 12x, divide by 12, I get x equals 7 over 12. Again, because this is an exponential function and the domain is all reals, doesn't matter what I get, I know it's going to work. All right, I know that wasn't the shortest video, but it was pretty fast. I suggest if you watch it on 2 times speed, you watch it again. What you'll be working on tomorrow is exponential equations. How do you solve for x when x is now in the power, not the base like in polynomial functions? Hope you have a good night. Peace.